Hi, these are the solutions for the partial exam. And first, we're gonna solve the questions that are theory questions. The question A says that you wish to decrease the speed of a wave traveling on a string to half of its current value by changing the tension in the string. And then we are asked to find what factor you decrease the tension in the string. So first we know. No pinta.
No entres en pánico.
No pinta.
Escúchale pausa, Rodrigo.
No, esto está interesante.
No, ya. Okay. Okay, so we are given the three primary colors, and we are asked to find the other. Well, we need to order them by their wavelength, from shortest to longest. Okay, so we know that the ultraviolet radiation has a higher frequency than the visible light does. So if we know that the speed of light is equal to the wavelength times the frequency, so here we get that the frequency is inversely proportional to the wavelength. So this means that the red light has a longest wavelength than the blue light. So if we order these colors from shortest to longer, we get that it's gonna be first the blue one, the yellow one, and then the red one. So for question C, we have that you're standing in the curve waiting to cross the street, and suddenly you hear the sound of a car, and that is approaching you at a constant speed and a frequency of 80 hertz. And then when the car passes you by, the frequency changes to 72 hertz. And so we have to find the speed the car is traveling to. So what we're gonna do first is that we're going to using the formula for the perceived frequency. And we know that first with the 80 hertz is the frequency times the speed of sound over the speed of sound minus the velocity. And for the 72 hertz frequency, we are going to write the frequency times the speed of sound. Then, because the car is passing you by and it's getting away from the person who's listening to it, we are going to use a plus sign here. And so we are going to make an equation with this with these terms here. So we get that it's 80 times the speed of sound minus the velocity over the speed of sound. This is equal to 72 the speed of sound plus the velocity over the speed of sound. So with this, with some algebra here, we get that it's going to be 80 times the speed of sound minus 80 times the velocity. Then again, this is going to be equal to 72 the speed of sound minus 72 times the velocity. So solving this, we get that 152 times the velocity is equal to 2,744, and we solve it and we get that the velocity here is 18 meters per second. Okay, so here we have a speaker, and 3 meters away from it there is this sound meter, and so here is 3 meters, and we have to find what will the sound meter be, and we're given the data of sound level of 80 decibels, and that's it. Yeah. So what we're gonna do is that with the formula for the sound level, first knowing that that it's 10 times the logarithm of the intensity over the initial intensity, sorry. Solving it for the intensity 1, we get that it's the well, we already know this value, that it's 1 times 10 to the minus 12 times 10 to the 8th, and here we're solving for the logarithm, so we get that it's 1 times 10 to the minus 4, and this is equal to the intensity, so intensity is also equal to the power over 4 times p times the radius, sorry, the distance. And then for the intensity 2, we're gonna the problem says that it's reduced by a factor of 25, so we reduce it by a factor of 25, and so what we're gonna do is that the intensity 1 is equal to 4 times 10 to the minus 6 watts over meter squared. And so solving for the sound level 2, we get that again with the formula of 10 times the logarithm of the intensity 2 over the initial intensity. We get that the result is 66.00 decibels. Yeah. Okay, so the question E. Yes. Okay, so the question E was what factor affected the speed of sound, and the correct answer is the temperature, because if the temperature increases, the energy that affected particles of the air makes them move faster, so the speed it's bigger.